Welcome to this module of the course, Open Science from Data to Publications. My name is Max Heber and I work for the KIM at the University of Konstanz in the Open Science team. This module was created in collaboration with my colleague Gabriel Schneider. This is the content of this module. First, we will clarify what we mean by research data, then we will deal with research data management, more precisely the goals and benefits of research data management. At the end of the module, I will introduce you to the research data lifecycle. What is your research data? As you can see from these images, there are many different types of research data. That's why it is also very difficult to come up with a definition of research data. In very general terms, research data can be defined as digital and analog data created during scientific activity, for instance during measurements, surveys or source work. They form a basis of scientific work and document its results. This definition comes from the information platform Forschungsdateninfo. But what is research data management? Research data management deals with the preparation, storage, archiving and publication of research data. Research data management is therefore an important part of the research process because it includes the planning of the research, the archiving of the results, especially the data, the reuse, but also the deletion, because storage space is not infinite. We will look at that in greater detail later when we go through the individual steps of research data management. What are the goals of research data management? The objective of research data management is to guarantee credible and transparent research. Research data management entails the responsible handling of research data before, during, and after the research project. In other words, to handle the data responsibly, that is, scientifically, technically, in terms of storage and backup, legally and ethically, throughout the entire research data lifecycle. To better understand this, I would like to do a short thought experiment with you. Currently, you are probably employed at one of the ERUA universities, but you may well leave your institution in a few years. Again, a few years down the road, someone has found you and sent you an email. In this email, you are asked to provide a few details about the data, for example, what a specific variable means or how you aggregated certain data values. It will take you some time to figure them out. With good research data management, you can prevent this because research data management includes good documentation of the data, precisely so that it can be understood without your support. We will discuss this in greater detail in the FAIR module. Why research data management? Well, you have just heard one reason, but there are many more reasons. Surely there are motivations for you as well, so you decided to take this module. Why are you doing research data management? Research data management includes good findability of data, but also knowledge preservation. Data loss is prevented by backing up the data, and research data management also facilitates collaboration because others can easily understand the data, thanks to good data documentation and data description. The sharing and reuse of the data is also a part of research data management. By publishing the data, you increase your own visibility, your research becomes more comprehensible for others. But you can also easily comprehend other research results by being able to view the data and understand how it was created. There is citation of data and a benefit for society as a whole through research data management, because it is no longer necessary to collect data twice, 3 times, 5 times, if others can reuse the data and conduct in-depth research on it. Another important reason is that research data management is a requirement in research data policies, such as those of universities, third-party funders or publishers. Finally, I would like to present the research data lifecycle to illustrate which individual steps exist in research data management and how they build on each other. First of all, the research data lifecycle begins with the planning of your project. You have set your sights on a specific research project and must first find out exactly what you want to do. Here you should already take a look at what data already exists that may be relevant to your research questions. Get an overview of what research data is available and whether you would like to reuse it. You can find out how to find these data in our module on repositories. You should also ask yourself how much data you want to generate, what tools or software do you want to use, How do you want to describe and document the data, and where and under what licenses do you want to publish the data? While planning your research project, you may also see that there is good data available for your research project, so you can adjust your research question in this regard. A data management plan can help you with all of these issues. Many organizations, as well as programs like Horizon Europe, also require them in order to acquire funding. Tools like Argos or DMP Online can help you create such plans. Both tools are available online for free. The second step is data collection. As your first step, please check whether any ethical or legal requirements are in place before you start collecting. Do you need approval from an ethical committee, for instance? If you are working with human participants, do you have all the GDPR, that is, the General Data Protection Regulation, requirements in place? Once that has been dealt with, you can carry out measurements, conduct interviews, or otherwise ensure that you obtain the data for your research. It is important that you make sure that you can actually use the research data. For example, that you get the consent of other people. How you collect your data depends heavily on your research design and its methods. Use methods and tools that are common in your research community to stay connected to the community. In this step, you should make sure to store your data in a structured way. You should ask yourself, who needs to have access to the data during the subsequent steps? This is where clouds or other collaborative working environments come in handy. Also, consider the 3-2-1 backup rule. You should save 3 copies of a file on 2 different storage media. One of the media is stored in a location other than your research site, so that if there is a fire, for instance, all backups are not destroyed at once. You should also follow a consistent pattern when naming your data, for example by including the data in the title or using unique version names. The third step is data preservation and analysis. This involves describing and annotating the data in a way that others can understand without having to ask you, following quality control workflows or cleaning up your data. This also includes adding metadata to the data. This is information about the data that helps other researchers, yourself in the future, to understand the data better. It can also become important for you if you go back to your data in future projects. Different science communities use different metadata schemes and standards. This is where data analysis comes into play. As you work with the data to answer your research question, ask yourself, what information is needed for other researchers to understand your steps? Document these steps. The fourth step is data sharing and publishing. You think about who should have access to the data, in what way, and where it should be published. In doing so, think about who you want to share your work with before publishing it. To publish your data, you can use repositories. Depending on the repository, you have different options in terms of licenses and access to the data. Use re3data to find a suitable repository. For more details on repositories, please see the repositories module. The fifth step is data archiving. The idea is to make the data available, usually for a minimum amount of 10 years, which has now become the norm. Here it is also important to look again at who should have access to the data and also how exactly the data should be accessible, whether, for example, open data is required or possible. For instance, if your data contains sensitive information about people, open access to it might not be possible without anonymization first. Repositories make data available in the long term. To use the repository, you should compare the guidelines of your funding organization with guidelines of the repository to find out, among other things, whether the funding organization agrees to the repository being given the right to change the data format, for instance. Such changes can be necessary to keep your data available in the long term. Then, data reuse takes place. Others can now validate your research and check what you have done. It can also make research more traceable and more transparent. You may get more ideas in this regard. Co-authorships, for example, have already come about in this way, and others can now use your data to plan and continue a new research project. Now we are back at the beginning of the research data lifecycle. A new cycle can begin. Here you can find the sources which we used to compile this presentation. the image sources. Thank you very much for your attention. Goodbye.